Hi, welcome to 1.1 on speed and velocity. Let's look at our vocabulary. Distance is how far an object has moved. Displacement is how far an object has moved in relation to its starting position. Here you must consider direction. Speed is the ratio between distance and time. Average speed is the total distance divided by the total time. Constant speed is a speed that doesn't change over time. Think cruise control. This is going the same distance in the same time consistently. Instantaneous speed is the speed at any given moment. The distance traveled in 1 second. Think what my speedometer says. Velocity is speed and direction of an object. On your formula sheet, you're going to want to add the next 2 slides. First is our problem-solving strategy called EWA, Equation Work Answer Units. E is the equation. We want you to write the equation that you're going to use. W is the work. Plug the numbers in to where they're given in the formula. A is the answer, meaning do the math. And U is the units. Units are important. We need to know what is being measured and how it's being measured. So on your formula sheet again, you need the equation V is equal to D divided by T, or velocity in meters per second is equal to the distance, D, in meters, divided by the time, T, in seconds. Graphs. We've already looked at them a little bit, but here we go again. The first graph that you're going to encounter is an XT graph. It's going to look like this, where X is the horizontal distance from the origin, right, or where you start. Since we're looking at constant speed, this will be a line of some sort. The second graph you get is a VT graph, a velocity time graph. Velocity time graph is just a picture of what the speed is or the velocity is at any given moment. This will be a flat line for constant speed. Since velocity is speed and direction, the way an object moves is important, and there are only 3 ways that an object can move with a constant velocity. The object could stand still. That would be a flat XT graph and a 0 VT graph. The object could move away from you or away from the origin. This would be a line going up from left to right on the XT graph and a flat positive on the VT graph. And then finally, the object could be moving toward you. This would be an angle going down from left to right on the XT graph and a negative velocity under the T axis on a VT graph. But again, it's a flat line. So velocity is distance divided by time. Distance is the change in position. T is the time. And on an XT graph, it will be the rise, change in position, over the run, change in time, or the slope of the graph. You're also going to have to calculate velocity. A turtle can move at approximately 0.05 meters per second. So how many meters could they travel in 15 minutes or 900 seconds? If distance is velocity times time, 0.05 times 900 is 45 meters. They could move 45 meters. And of course, there's a song. Be sure to check that out on my YouTube channel.